Good afternoon, everyone. So we're going to find the surface area and the volume of this composite object, but you'll notice that the dimensions are not all given to us in the same units, right? Most are in meters, but this part is in yards. So whenever we have an object where the dimensions are given in different units, we have to pick one of the units and convert them all into that one. It doesn't matter which one, we can choose arbitrarily, but they need to all be given in the same units. Now, I'll remind you guys, the conversion between yards and meters is that 1 yard is equal to 0.9144 meters. That's conversion you can find online, anywhere you want to look. And so, since we have 3 dimensions in meters, let's convert the yards into meters. So we'll do our classic unit conversion strategy. 2 yards times 0.9144 meters for every 1 yard. I really like this strategy because it's very straightforward to see if we did it correctly. The yards should cancel out as the units do, and we should end up with meters as our final answer, which is what we're hoping to do. Now, the numbers just kind of fall in line, and so if the units cancel out the way they should, then we can simply go ahead and calculate 2 times 0.9144 divided by 1. That's easy enough. That's 1.8288 meters, or for efficiency of calculations, we'll round that to around 1.8 meters. Okay, good enough. So that means that this dimension here, the length of the cylinder in the center, we'll write as, 1.8 meters. Pardon my mess here. 1.8 meters. There we go. So now, with that taken care of, we're ready to start computing the surface area. So the surface area is going to be the surface area of this cone plus the area of the cylinder plus the surface area of the second cone, right? Now, we are given the radius. That means that the radius is also 2 meters here, but we're only given the slant heights, right? For the surface area, that's going to be okay. So for the surface area, we are going to have, from the first cone, we'll have pi rs for the lateral area of the cone, not plus pi r squared, because we're not going to count the circle at the bottom. Right? That's going to be engulfed inside of the cylinder, so we won't actually see that circle at the bottom. Okay. Next, we'll have, again, the cylinder in the middle. We're not going to see the 2 circles at its 2 sides. We're only going to get the lateral area of the cylinder. And the lateral area of a cylinder is 2 pi r h. Its circumference, 2 pi r, times its height, h. And finally, plus pi r s of the second cone. Let's call this S2, the second slant height, and let's call this S1. It's really important to call your dimensions things that you can easily reference later on in your solution. That way you're not mixing them up, okay? So I'll call this S1 for the slant height of the first cone, and pi times r times S2 for the slant height of the second cone, right? And now we are ready to plug in our values. So we'll have pi times, they do share a radius of 2. So that's nice. 2 times S1 is 3, plus 2 times pi times r is 2, and the height is 1.8. Again, we need the same units, right? So we're going to use the 1.8 for the height of the cylinder, right? And plus pi times 2 times S2 is 4, okay? Now, we can simplify this a little bit. Pi times 2 times 3, that's 6 pi, plus 2 times 2 times 1.8, that's 4 times 1.8, that's 7.2 times pi, and plus 2 times 4 times pi is plus 8 pi, and now we can conjoin those. We have pi's, pi's, and pi's, so 6 plus 7.2 plus 8 is 21.2 pi, and now you can throw that into a calculator. 21.2 times pi, that'll be 60 something. 21.2 times pi is 66.6 meters squared. And that is our surface area, okay? So we needed to get all in the same units because that surface area in the end needs to be in some squared units. It can't be some mixture of meters and yards, right? Or feet or anything else, right? Now for the volume is going to be the volume of the cone on the left, plus the volume of the cylinder, plus the volume of the cone on the right. So for the volume, we need the vertical heights of the cones. We need those vertical heights, right? And so you can see that a Pythagorean theorem application comes up. We have a nice right triangle over here. We want to know that I guess horizontal height, that height from the apex of the cone down to the center of its base. And so that's not the hypotenuse. And so in this case, let's call this H1 and let's call this let's be consistent. Let's call that H1 and let's call this H2 in the same way that we did S1 and S2 for the slant heights, right? So for H1, I'll do it over here. H1 squared is 3 squared minus 2 squared, right? This is the radius of 2, right? 2 is the radius, so it's the same on both sides. So 3 is the hypotenuse of the right triangle, right? H is not the hypotenuse, and so H1 squared is equal to 3 squared minus 2 squared, right? And so we have H1 squared is equal to 9 minus 4. H1 squared is equal to 5. And so H1 is equal to the square root of 5, which is roughly 2.2. Okay. And now we can do the same for H2. H2 squared is going to be, again, H2 is not the hypotenuse. The hypotenuse is the 4 meters, right? This is the cone. And so 4 squared minus the radius of 2 squared. 4 squared minus 2 squared. H2 squared is equal to 16 minus 4. H2 is equal to the square root of 12, which is roughly 3.5. And so that will be our second cones in this case, since it's sideways horizontal height, if that makes any sense. And now we're going to use these values to compute the volume. So we'll have volume of cone 1 plus the volume of the cylinder plus the volume of cone 2. Make sure I have enough space here. The volume of cone 1 is 1/3 pi r squared h. So that'll be 1/3 pi times r is 2. And h is, for the first cone, h1 is 2.2. Plus the volume of the cylinder is pi r squared h. H is 1.8, r is 2. So pi times 2 squared times 1.8 plus, again, the volume of the second cone is, again, 1/3 pi r squared h being its horizontal height, h2 that we just found. H2 we found to be 3.5. These are meters, to be crystal clear. So we have 1/3 pi times the radius of 2 squared, right? Radius of 2, and its horizontal height of 3.5. And now for the volume, we're ready to sum this all up and find our final answer. Let's plot this into a calculator. These are going to be irrational values. So we'll have 2 squared times 2.2 times pi divided by 3 plus 4 times 1.8, 4 times 1.8 times pi. I encourage you to try to plug this into your calculator all in one step, in one foul swoop, just to practice your efficiency. And finally, for that third segment, we'll have 2 squared is 4 times 3.5 times pi divided by 3. So 4 times 3.5 times pi divided by 3. And we get a volume of, let's go to one decimal place, we get a volume of 46.5, and our units are in meters. Volume is a 3-dimensional measurement, and so we have cubic meters as our units of volume. And there we go. So this was a nice problem, some unit conversion, some applications of Pythagorean theorem to find missing dimensions, surface area, volume. I hope that helps. I hope you're making connections between all these things, and thanks for watching.